All right, so in this question, we are going to look at the identification of how many terms do we need to add in order to make sure that the error of our estimation of the sum of a convergent series is not larger than 0.0005. Now, there is a theorem that talks about how many terms you need to add, and let me demonstrate what they are saying. Sometimes, though, it is a little frustrating with the decimals that I don't really see exactly the same thing that they promise in the theorem, but let's check it out. And let's just follow the theorem the way it is. Okay, so what we're going to do is define a sequence equal to, now I will also include the negative 1 to the power n plus 1, but just remember that when you are judging how many terms, you actually don't care about the negative. You're just taking the absolute value of what it is. But I will include it because I will need to also estimate the sum. So I do need to open parentheses here. And then I will take the multiplication sign and then 6 divided by n to the power, I've got 13 halves here. Okay, so this is definitely a convergent alternating series because the 6 divided by n to the power 13 over 2, which is 6.5, is like 6 divided by infinity. So that goes to 0. It's also decreasing. You can check with the derivative. Derivative is going to be negative. So you know that by alternating series test, this series does converge. You just want to know how many terms do you need in order to estimate the sum. Okay, so what you're going to do is start evaluating the terms of this sequence, starting with the first one. And just keep going. So I'm going to do a 2, a 3, a 4 until I get a term that is less than 0.0005 in absolute value. Now, this one, what also is a little bit confusing is this scientific notation. Basically, what that means is that you're taking that dot and moving it 4 to the left. So it looks to me like if I take the absolute value of this is going to be 0.30, right? And then a 7. But that's actually not yet less than 0.0005. So I think I need probably one more. And yes, so it looks like A5 is the first one where it was actually less than the number that they give you. Now, the theorem says that that means you need one less number of terms. So basically, you need 4 terms. Okay. Somehow, though, when I do it, I feel like 4 is not enough, but the theorem says you're supposed to take one less than like the first number that's less than that. So I don't know. Let's figure out what the sum is. Okay. So what you need to do is if it's 4 terms, then you're just going to add a 1, a 2, a 3, and a 4. And then you want to round that. It doesn't say, but you want 3 decimal places. So you want to go ahead and round this answer. So I'll just say round and then answer to 3 decimal places, and that should work. Now, I wonder if I use a fifth term. No, see, like the fifth term didn't really do anything. The sum is still the same. So that probably works. So probably that theorem works. So it's supposed to have 4 terms.